All right, so today we're going to talk about interval notation. And the reason this is important is because I'm going to be asking you to use this pretty much throughout the whole year. Like this comes up over and over and over again. Okay, so when do we use interval notation? We use it We use it whenever we are listing all of the x values of something. So what is another word for all of the x values? You may remember this from Algebra 1, you may not. All of the x values are called the domain. So some things are going to say, list the domain of the function, or whatever. Okay, all of the y values, those are your range. So if you see range, think y, domain x for always. Okay, number 1, this is a discrete function. Okay, what is discrete? That means it's a bunch of dots. It is the opposite of discrete is continuous. So this definitely is not continuous, right? Those dots are kind of all over the place. So it's going to be a little bit different. So you're going to list all of the x values for this. Well, I see this point right here on the far left is -5, 5, right? This one, we'll do the one below that. That would be -3, 2. I'm just going to go ahead and do them all. I'm not going to do this every time, just so you kind of get the idea. This is 0, 1. And then this one is -3, -3. Okay, domain. What are the x values? Well, it's going to start with -5. There's also a -3, right? There's 2 of them actually. So when there's 2 or more, you only need to write it once. Don't worry about writing it multiple times. Then I have -1 and 0, and I believe that's it. Okay, usually on domain and range, you write it in order from least to greatest. That's kind of the proper math etiquette. And since we're writing a list, we're going to have to put what's called curly brackets around it. And it looks kind of fancy. They take some practice. You'll get better at them. Those are curly brackets. So that's telling you that is the list of values that represent the domain. Okay, range. Range is the y values. Again, you try to write them in from least to greatest and also with curly brackets on it. So let's go -3, then 1, 2, and then 5 occurs twice, but I'm only going to write it one time. All right, next one. So this one, I'm not going to label the numbers, but the domain, this is a discrete function, or discrete relation, I should say. -4, -2, 0, and 2. Those are all of the x values for those coordinates. If it helps you, go ahead and write it out like we did on the other ones, but I'm just trying to save a little bit of time because I know this video is going to be long as it is. Range. Range is the y values. What is the smallest y value? Well, that would be right there at -2. And it looks like 0, 1, and 3. Okay, so the next one. Now, what is this? Well, this is a line. It's continuous, right? It's not discrete, not a bunch of dots. It's a continuous line. What do you remember about lines? Well, they go forever in both directions. So they continuously go. We don't draw it because it goes on forever and we will never have enough paper, right? And it just takes up too much room. So domain, what would be the smallest x value for this? So what is the smallest number to the left that this will go? You're thinking like -7. Well, it does hit -7, but it keeps going. It goes to -8, -10, -100, -1 million. It's going to go on forever until it never actually gets there, but it approaches -infinity. Okay, this is the actual interval notation. So -infinity is what's called the lower bound, how far left it goes. The upper bound for domain is how far to the right it goes, and it goes up to +infinity. Okay, so now you're not quite done. So notice I put a comma in the middle. So you're going to have 2 values, a comma in the middle. This is how you write in interval notation. So let's talk about one thing. I'm going to go off on a little bit of a tangent. So if you remember back from, I don't remember what grade, 8th grade or so, and you had something like this, I'll draw two of them, 3, 4, 5, okay? So say you had, you probably had an open dot and then an arrow that goes like this, and then maybe a closed dot, an arrow that goes like that. Okay, so whenever you had an open dot, you had to write it in a certain way. So it was 2 is your lower bound, and then it goes up to infinity because it goes forever to the right. Okay, so does it hit 2 or does it just get really, really close, like decimally close to 2? The answer is it just gets really close. It doesn't ever actually hit it. So then it's going to be a parenthesis. And I'm leaving that other side blank for now, but I'll come back to it. Okay, this other one, it's going to go from negative infinity, comma, and then 5. Does it hit 5? Because 5 is the top. Does it hit 5 or does it approach it? Well, it hits it, so then that means it's going to be a bracket. Okay, so now on these, can you ever actually hit infinity? And the answer is no. So it's going to have to be parentheses. So whenever you think you reach infinity, I can always say one more number that's bigger than that, always. So you can never actually hit infinity. Same thing goes with negative infinities. So on here, we're going to have parentheses around those. So let's do a little star. Infinities always get parentheses, okay? Always, never brackets. All right, so now back to this problem. Range. So range is the y's up and down. So start with the lower bound. How far down does this go? Well, the answer is it goes forever down to negative infinity. Then a comma or a parenthesis around that. Then write your comma, of course. Then the upper bound is positive infinity. So it's going to go on the right side and close those parentheses. Again, not a bracket. All right, this one's a little bit different. If you notice, this is a segment. This doesn't come up a lot in this class, but some. Okay, so domain, lower bound. How far to the left does this go? Because that would be lower bound for domain. And it looks like right here at -4, the x value. Okay, I'm not worried about the y. How far to the right does it go? Goes to 2. Right, that's the farthest right point. All right, so now we got to do either parentheses or brackets. Does it hit -4? The answer is yes. It hits it because that's a closed dot. So that's going to be a bracket. And then does it hit +2? Also yes, bracket. Range, how far down does it go? Goes down to -2, right? That bottom point is at -2 on the y-axis. The top point is +4. Bracket it because again, they're closed dots. Try this one, pause the video, try it on your own. Okay, let's see what you got. So domain, lower bound for domain, it looks like -3, and it's gonna be a bracket. Upper bound is 7. Range, lower bound is 0. Upper bound is +6, also bracket. Okay, this one's a little bit different. This is a line, but it's not just any line, it's a vertical line. So I'm going to skip domain for the moment and let's go to range. So range, what is the lower bound for this? How far down does it go? Well, the answer is all the way down to negative infinity, right? Because it goes forever. So we got to put a parenthesis around that for sure. What's the upper bound? Well, that would be positive infinity, also parenthesis. Okay. Domain, what is the domain for this? Well, it looks like the only x value this line is ever going to hit is at -3. Okay, so if you just want to write domain is -3, that's okay with me. You don't really need brackets around it because it is just one number. It's not really a list, but if you did, I wouldn't count it wrong. Okay, so that is it for that one. Okay, this one is, if you remember, if you've graphed this before, this is called a parabola. Don't worry if you don't remember. I'm going to teach you how to graph this again this year. So domain, x value. And keep in mind, these arrows go all the way this way, okay, forever and ever. So how far to the left? That's negative infinity. How far to the right? Positive infinity. And then parentheses around both, of course. Okay, because it's going to keep going to the left and keep going to the right. All right, range. What is the range of this? The lower bound. How far down does it go? Looks like right here would be the tip. So what is that? On the y-axis, we're talking about range, so this is y value. That's 0. Does it hit 0 or does it approach 0? And it looks like it hits it because it crosses at that point. So it'd be 0, comma, and then it goes all the way up forever, so that would be infinity. So you can't have something that has a bracket and a parenthesis. That's definitely fair game. Okay. This is actually the graph of y equals the square root of x, which you're also going to learn how to graph this year. Don't worry, it's not for a couple units. Okay, so domain, lower bound for the x coordinates. Looks like the farthest to the left it goes is right there, so that would be 0 with a bracket because it hits 0. Upper bound is going to be all the way up to positive infinity, and infinities always get a parenthesis. So another bracket parenthesis problem. Range, how far down does it go? Well, it looks like it goes to 0 on the y-axis as well and goes all the way up, even though it looks like it's kind of leveling off, it's not. It continues to increase. So it is going to be up to positive infinity. Okay, this one we're actually going to learn how to graph this unit at the end. This is the graph of an absolute value graph. So it's negative absolute value of x. Fun fact. Don't worry, you don't have to remember that. We're going to go over it later. Okay, so the domain, how far to the left does this go? Goes over to negative infinity with a parenthesis. And how far to the right? It goes all the way to the right forever, positive infinity. Parenthesis. Range. How far down does this one go? This one's a little bit weird. Okay, looks like to me it goes down forever. Okay, so this would be negative infinity. And then what is the upper bound? Looks like it stopped. Like this is the highest it's going to go right here. So that would be 0. And it hits 0, so that's going to be a bracket. Okay, 3 more. Ooh, we got a circle. You're also going to graph this year. Okay, domain, how far to the left does this go? Looks like -4, throw a bracket around that. And to the right, it goes to +4. Right, that's it. Range is gonna be how far down? -4, how far up? +4. Bracket, because it hits both of those. Cool. This one, you're not probably going to see this again this year. Oh, I take that back. When we do piecewise functions, you will see something like this. Okay, so domain, what is the lower bound? So how far to the left? Looks like -2. Does it hit -2 or approach -2? And the answer is it approaches it, so it doesn't actually hit it, so it's going to be a parenthesis. And yes, I will take half a point off if you don't have the right parenthesis or bracket, whatever. Okay, how far to the right does this go? Well, it goes on forever, so that's going to be positive infinity. Okay, range. What is the lower bound of the range? Looks like +2. Does it hit it or approach it? The answer is approach, and I know that because of the open dot. What's the upper bound? Well, that goes up forever, so parenthesis. This one's kind of a weird one. It almost looks like whenever you get to pre-calc or trig, whichever route you decide to take, it looks like one of the sine or cosine graphs, but we're not going to do that this class. This is kind of misleading how it's drawn. It's actually going to continue to go this way forever based off of this drawing right here. So the domain, well, this would be negative infinity to positive infinity, right? Because it's going to go all the way to the left and all the way to the right. Range, same thing. It goes all the way down and all the way up. Okay, so that's kind of a weird one just for fun. All right, that is it for interval notation notes. Thank you for watching. Have a great rest of your day.